Okay, so let's get going here. Sorry. Great, so again, this diagram I'm going to be reproducing, going to be give me a bit of one or two sentences about each one of those topics because you're going to be covering throughout the 2 nights. So HTTP takes care of this communication here. I have two metaphors, two comparisons to try to make HTTP a little bit more understandable. HTTP, it's like, actually there is, let me see if there is another component here. Let's hold on that comparison. Let's look at this video first.
Let's do it. First point, most basic point, is that HTTP.
So this guy will go through 6 points about HTTP. What it is, what are the characteristics of HTTP, and the applications of that, okay? So let's have a look here. Tell me if the volume is okay.
HTTP follows the standard
okay?
client-server model or request. Most basic point is that HTTP follows the standard client-server model or request-response model. So I often use kitchens. I always use kitchens as my analogies because, I don't know, it's really convenient, but we've talked about this before. Basic client-server model, you're a person going to eat at a kitchen, you're a client, and the kitchen is responding to your request. So you go in, I want a Big Mac. The kitchen goes, all right, here's a Big Mac. So the web browser you're using right now to watch this video, or any web browser that's running on your mobile phones, those are the clients to HTTP. And the servers for HTTP are all those web applications like YouTube, Facebook that are sitting on the cloud, owned by different companies and just on the internet. All right, so point number one, really basic client-server model, and that's what HTTP follows. The second really important thing to understand about HTTP is that it's a stateless protocol. And what do we mean by stateless? What stateless kind of means is that every single transaction you make through HTTP is independent and it's not related to any other transaction. So let's just take a couple analogies, like flipping a coin. Flipping a coin is stateless, right? Heads, 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 tails, tails. Just because you got heads 5 times doesn't mean you couldn't get it with the same probability the next time, right? Flipping a coin is stateless. So even though HTTP is kind of a stateless protocol, you'll see that a lot of web applications still track your state somehow, right? And they do this via these things called sessions, cookies, and a lot of kind of stateful man.
Yeah, so this is important. See, even though HTTP, the protocol, is stateless, it does remember stuff, but there are other mechanisms that we can put in place that will remember things for us. On the client side, we can have cookies in the client side. Cookies are small bits of information stored in the client's website, in the browser's website, in your local web browser as you browse through the web. So those are cookies. On the server side, we have this thing called sessions, which will keep track of your presence from when you started browsing the site up to when you leave the site. So the client knows a bit, the server knows a bit, but the protocol, HTTP, itself, it does know past or present, or present, or no, not to mention future. It just knows how to do the transaction, request and response, request and response, okay?
Management of how web applications work with all their clients, but that's for another video, all right? So even though HTTP itself is stateless, you still get the functionality of state through other mechanisms. So remember that. The third important point about HTTP is that it's an application layer protocol and it sits on top of a transport layer protocol. 99.9% of the case, HTTP uses TCP as its transport level protocol. So if the transport layer is here, the application layer is a little above it, all right, in the stack of things. We can't get into the details of TCP in this video, but what it really does is it defines how data is sent from one place to the other, how the data is formatted, how the packets are sent, how do you acknowledge things. It's kind of dictating the actual transport or the communication of the data itself. That's what TCP does. HTTP.
Okay, there is an analogy that I like to make about HTTP and TCP. And here it is. And let's see if you are able to visualize that. Again, it helps me to clarify this concept. Think about a highway. In a highway, you have trucks carrying loads of things. So highway, trucks carrying packages inside, carrying loads of stuff. I know it might be foods, it might be other types of products. Let's bring that analogy to our context here. Think about the highways as the wires and the wireless and the wired communication that we have on the web. Highways are the physical connections between computers and servers, which we have, as the wireless network, as the wired network. What TCP is the truck. It's a truck that keeps carrying stuff back and forth. TCP does not care what goes inside of it. The truck does not care what's inside of it. It just knows how to go from point A to point B. TCP knows how to bring stuff from point A to point B. What is inside of TCP is HTTP. It might be a request, it might be a response. So I find it to be a good metaphor to compare and understand this. What is TCP? What is HTTP? Again, HTTP, when you think of HTTP, you have a request and you have a response. Okay?
HTTP sits above that on the stack, right? So from HTTP's perspective, it doesn't care about how the data is sent. Those are details it doesn't care about. All it cares about is, I request a web page, I want to get some data back. I request that web page, I want to get some data back. So it never cares about all those little details that TCP handles. So HTTP up here, TCP right below it. All right, on to the fourth important thing about this protocol is that whenever the client requests something from the server, it always specifies a special action or method along with it. If you're a developer watching this video before, I'm sure you've heard of all these different methods or actions. Get, post, delete, but these are all special actions to be performed by the server. Get is really simple. I just want to get a page, read a page, all right? It's always read only. I want to get a resource. Post is you're creating something new. So you're creating a new item in your shopping cart, or you're creating a new friend in Facebook, but post is always for creating a new object. And delete, self-explanatory. Fifth most important thing about HTTP is that it defines response status codes that the servers make back to the clients. I'm sure many of you have encountered some of these before. 200 means A-OK, 404 means not found, 500 means you effed up. But if you look at the documentation for HTTP, there's a lot of these numbers defining what all the different status codes means, but what's really difficult is that it's actually up to the programmer to return the proper status codes, and more often than not, you don't really return the proper status code many times. Okay, so the sixth and last core thing to understand about HTTP is that it supports these things called headers. all a header is, it's really simple. All headers are tiny bits of custom information that you send along with your request and with your responses. The main purpose of headers and all this custom little bits of information is to kind of tweak the operation of the request. So let me just give a few examples to hopefully make it more clear. One header that you can include in the request side of things is the content type of the data that's returned. So you could say, I want a text file, or I want an XML file, or I want a JSON file, but it's up to the client to be like, I want some data, but I actually want to choose what type or the format of the data I want to get back. So it's going to send a special header to be like, I want it as a text file. And the server is going to recognize that and respond with a text file. So what we just talked about was actually a header that the client uses on the...
That's okay. I'm going to talk more about headers in a second. Okay, so I hope that this gave a bit of an overview of HTTP and the fact that we have those pairs, those two actions, request from the client, response from the server. Let's keep moving forward here. The guy in the video was talking about headers. So a request and a response, they have a certain format. They have two elements, two basic elements. They have a header and they have a body. When you request google.com, it comes back to you as a page. What you see on the browser is the body of the message. The header is hidden from you. The header, only the browser cares about that. But I'm going to show you right now how you can see the header of a request that you do to a website. I'm going to show you that. This is an example of a header. I want to jump to the browser and show you that. We're going to be using Google Chrome quite a lot because it has a good set of developers too. So I'm going to just open a new tab. I'm going to press F12, function 12, and that will open this area either at the bottom or at the side of your browser. It will show details about what's going on behind of that page that you have loaded there. I'm going to load google.ca. When I do that, you're going to see that files will start to show up here. Those are the files related to this request that I'm doing to google.com. Okay? So I'm going to hit enter. And here are the files. I just clicked somewhere that I should not have clicked. Let me try refresh this. Okay, I just refreshed the page. If I go to the very top, the very top has the first request that I made. I made the request to google.ca. When I click there on google.ca, on the right-hand side, yeah, right hand, yes. You see the headers. You see a header. This is a bit too low. I'm going to try to increase the space here. There's a limit there. There's a header for the request. There's a header for the response. Again, request, who built the request? I did. I requested from the browser to the server. So this is the header for my requests. This is the header for Google's response. I can explore that. I'm going to expand here the request header. Again, we have a few tiny bits of information. It's usually a pair. It has a property and a value. Property and value. Property and value. And I'm not going to go through each one, but I'm going to focus on one that is more relevant to us. The guy in the video was talking about actions, get, post. When I request google.ca, my method is a get method because I'm getting a read-only piece of information from the server, from Google server. So this can be called the verb, the method is a get method. because I'm just getting read-only information from the server. Okay? Now, there are a bunch more tiny bits about the header, but I don't want to focus on all of them. Just this one here. Method get. You can see the entire set right here, including cookie. Cookie, as mentioned in the video, is a piece of information that can keep track of states. So, you see, before, I went to Google before. So Google had a cookie that recorded stuff about my interactions with Google before. And in my request to Google, it sent this cookie to Google as well. See how big this is? It has a lot of information here because Google tracks a bunch of stuff from us. Okay? And there's a lot here. That's the reason why. Okay? So this is the cookie. Cookie that goes to Google, and Google can find out a lot of information about us with this kind of stuff here. This is the request, my request. Let's have a look at the response. I'm going to just collapse this and expand response header. So this is the header part of the response that Google sent back to my browser. Okay? So let's have a quick peek. Again, tiny bits of information. A property and a value. A property and a value. Here you see alt-CSVC. Have no idea what this is, but again, it's yet another little piece of information that goes back and forth. Content length. It shows the size of the page. I think this is in most likely in bytes. Content type. I want to bring to your attention the status 200. What does 200 mean? Means okay. Means that this request, the response is okay. There is no error between the server and the clients. So it's an okay response. Always request, response. Both of them have headers and body. This is the header. What is the body of the response? What is the body of the response? The web page. This is the body. What we see in the browser is the body part of the response. Okay? Great, great. Let's see. Okay, so we have jokes there. Okay, let's keep things serious for a second. Okay, so I show you a sample of a request header in a request in a response header as well. As I said, there are certain slides that I'm not going to go through each and every single detail. URI, you're gonna hear the terms, this term here and there, URI, URL. What is an URL? URL. Any comments? The URL. It's a web address. Okay, it's the address for a page, for a site. A URI is something a little bit more generic. It can be a URL, but it can be an email address. It can be an FTP address. Who knows what FTP is?
File transfer protocol.
File transfer protocol. It's usually the way that you can upload files to a server. Okay, so again, FTP is a type of URL. Sorry, it's a type of URI, but it's not a URL. All URLs are URIs, but not all URIs are URLs. Oof, mouth full. This is just defining a little bit how the URL structure works. We have the schema, it can be HTTP or more commonly nowadays HTTPS from secure, okay? Then you have a few other pieces of information. You have the host, which is the domain, like google.ca, centennialcollege.ca. You can have a port number. What is the default port number of websites?
8443.
80. 80 is the default one. And that's why, because it's the default one, we don't need to specify that in the URL. When you see a URL that has a column and a number, it means that it's specifying the port number to communicate with that server. By default, it's used, 8 is the one used on most commonly. If you want more information, you can visit this, this address here. Again, those are, as I said, today is a kind of a slow day, not coding, nothing about coding, just some general overview. This is just talking more about the format of the message, the fact that it has a header, it has a character, and then it has a message body. The first line in the header, it's called start line. And again, I'm not going to get into details here. This is just telling the kind of format that you see in header fields, like you have the field name, column, a space, né? Optional white space, and then you have a field value. Okay, not going to hammer those kinds of stuff, but this is a good slide to have a quick look at. There are a lot of different methods when you request. You have the most common one, a get, which gets read-only information. We saw where we can find this information on our message here, you see, on our request header. See, the method is get. But you can also find those other types of actions. I'm not going to cover each one of those. We're going to focus on two. Get is the most common one, followed by post. Post when you need to change information in the server. When you fill out a form and you click submit button, that information in the form needs to travel back to the server. So it's not using a get, it's using a post. A post is to send information, to send data from the client to the server. That data will be stored, will change data, will do something there. But when we are changing data, saving data, modifying data, we use a post. When we just want to read data, we use a get. Let's not confuse that. Let's not, and you're going to see that it's possible. Let's not use a get to send information to the server to save it, because it's not secure. Okay, it's not the proper way. The proper way is by using the method post. Okay, let's have a look at this other video here.
HTTP is an acronym for Hypertext Transfer Protocol, literally a protocol used to transfer hypertext, which begs two questions. What is a protocol, and what is hypertext? In this context, a protocol is a system of rules that allow communication of information between different entities, like computers. Hypertext is a somewhat outdated word for text that is displayed on a computer screen that contains hyperlinks to other text, so web documents. So, the Hypertext Transfer Protocol is the set of rules servers and browsers use to transfer web documents back and forth, which is why every URL you type into a web browser starts with HTTP. That's a nice definition, but it doesn't tell us much about the nature of HTTP, what it is. So let's dig in a bit deeper. One of the core principles of HTTP is that it is plain language and human readable. When you see an HTTP request, response, or message, you can read it out loud and make sense of it, even if you don't necessarily know how the technology works. As an example, all HTTP request methods use simple human language verbs: get, post, put, delete, and so on. You don't need to know anything about computers or computer networks to get what I mean. Another principle is that HTTP is a stateless protocol. That means each individual request sent over the protocol is unique, and no request is connected to another request. To put it in another way, HTTP has no memory of previous requests. Go to a web page with a photo gallery, and it'll show you the first picture. Go reload your browser or type in the URL again, and you get the first picture again, because HTTP has no memory of you making that first request. This statelessness ensures users don't get trapped in or placed in the middle of sequences of content, but it also means they can't walk their way through sequences because the requests are not connected. To fix this, HTTP allows sessions, stored states shared between the browser and the server. If a visitor is flipping their way through a photo gallery, the browser and server can exchange information about where the visitor is in the sequence by passing information back and forth in the form of cookies. Reload the page, and the browser sends along a cookie to the server saying, hey, last time we spoke, we were looking at the third picture. Start there. This means while HTTP is stateless, it is not sessionless. That passing of cookies that allows HTTP to preserve sessions is made possible by the extensibility of HTTP. When requests and responses are sent back and forth over HTTP, we can include HTTP headers with additional information. These headers can carry information about everything from what type of client sent the requests, the server configuration, and the time and date of the response, to how and for how long the client should store the data, what format the data is in, those cookies used to track sessions, and so on. Which brings us to the last basic principle. HTTP works based on request-response pairs. Every action performed over HTTP starts with a request using one of the HTTP methods and ends with a response containing an HTTP status code saying what happened to the request along with the data like headers and content.
Okay. For some of you, this may be a little too much repetitive, but I'm aware of that. I'm aware that there are some repetition here, but I want some of those concepts to stick around in your heads for the long run. That's why I use a lot of repetition, okay? Let's just talk a little bit about the status codes. Again, when we just went through our example, our response header has returned the status code 200. It means that the server is okay. The message was okay. There was no errors here. But there are quite a few different types of messages that can come back from the server. For instance, message that starts with the number 1, 1, 0, 0. Those are more informational messages. To be honest, I have never seen them. So if you spot one, let me know, take a picture. I want to see that. 200. It's the okay message. Okay? Now, there are different types of OKs. Again, I have only seen the most common one, which is the 200. But as you can see, anything that starts with 2 is a successful message back to the client. Then we have a series of messages called the 300 messages, which are redirection. What is a redirection? It is moving to another place. Moving what to another place? The user? Yeah. It will move the user to another place, yeah. Can you give me an example of when something like that would happen?
When you browse, you see the ads.
Yep.
When you see the ad, sometimes if you download something, they redirect you.
Okay, that's a redirection.
Well,
Yep.
well, there are some sites that when you enter a wrong rule, they redirect you on the page, or sometimes it happens that webmaster have to change the rule because they need to do a better positioning, better SEO, and so they just use another rule, and if you come to the back rule, they redirect you to a new one in order not to break anything.
That's a good definition as well. Just so you can all listen to that. A redirect is this page used to be this place. Now it's no longer there, it's somewhere else. So you need to imagine this. Imagine that you have a site that was built 10 years ago. And last year, the site was recreated. imagine that there are so many links pointing back to the old sites. What will happen with those old links? They will be all broken? You have to take care of those old links. Now, the way that works is that you can make rules in the server that says, oh, if someone comes looking for this old location, send them to a new location. So it's a way to say, yes, I know that this page used to be here, now it's somewhere else, here is where it is. And then this is used for search engine optimization, where when you search for a website in Google, it has a link there. The link now is pointing, let's say, to an old page. You don't want that anymore because there's a new page now. But you don't want to lose that search position in Google. What you do is you create a 301 redirect, and that 301 redirect tells Google, hey, this page is no longer sitting here. It's sitting right there now. What Google does? Google updates its index with the new location. Anyway, long story short, 301 redirect is used to reposition locations, pages from one place to a new place, okay? When things get moved around. Maybe it's a permanent move, so you send a 301 redirect. Maybe it's a temporary move, so you send a 302 redirect. Client errors. What is a client error? Is when, let's say, you try to access a page that doesn't exist, or you are not authorized to access that page. It requires an authentication, or the server forbids access to that page, okay? So those are client-side errors. And the last set of errors are server-side errors, which are the 500 errors. This is an error that is triggered in the server. Maybe it's a piece of code that didn't handle problems properly, and it crashed the code, so it returns a 501, 503. Okay, so those are the different types of status codes. Your turn. So we're gonna do a quick quiz, just to check how we're doing. It's a 3-minute quiz. I'm just gonna open that. You're gonna use Nearpod. So again, access nearpods.com. So nearpods.com, and let's go to this section here. Okay, so again, nearpod.com, XGCOI. Just going to give a few minutes here for us to have a look at that, and we'll do it together. Okay, while you do that, I'm going to take a quick attendance here. XGCOI. Justin Jot. I might be misspelling. Okay, mispronouncing. Muskan. Jungshil. Yeah. Arshdeep. Arshdeep. Yep, okay. Alessandra. James. James. Shane. Lascelles. Luis. Yeah. Ari. Reneton. Rohan. Dasson. Hassan. Isaac. Isaac or Isaac? Isaac. Jungmin. Nayu. Yongui. Yep. Dimitru. Hyewon Sioko. Hai Wong Siok. Oh, is it you? I'll call you? Philip? Okay. I'm going to try to remember that. Guan Yang? Stephen?
Noseworthy?
What's that?
Is it noseworthy?
Yes.
Okay, yes, it's me.
Tangila? Brandon? Carmelo? Sunil? Huang Chong? Yeah. Charles? Huai Huang? Huai Huang? Yep. So maybe I mispronounced. Is that yours?
Yeah.
And the first one, I think this was the one, Hai Wong Chong. Yeah, so, I don't know, if I miss anybody, let me know. Arthur? Okay. And did I miss? Can you come here? Last name, Shin? Okay, so
Yeah, that's correct.
that's you. Hanju? Chong? Okay. Anybody else? Did I miss? Okay. Okay, perfect. So let's get this going. Okay, so 3 quick questions. The following are all parts of HTTP messages except start line. Yeah, the first line of the header is called the start line, okay? So we have headers, we have body, we have a start line, but there's no such a thing as a footer. What is the name of the transfer protocol used by HTTP? TCP. So again, TCP, HTTP is on top of that. The transfer protocol, the application protocol is HTTP. What are the 2 most common HTTP methods? Get and post. The other ones are useful as well. They have their places, but the most common ones, get and post. Yeah. But the most common ones, the ones that you're going to be dealing with the most, are gets and posts. Let me move forward, and we have a second set there. Let's just give you hopefully you still have everything open there. Let's just it's the same code. I'll open it up once again. I'll give 2 minutes there so we can get this one done quicker. Four questions there. Yes. The codes? Yeah, there might be. There might be ones with multiple answers. Okay. Sounds like a cash register. Okay, so which of the following is a characteristic of HTTP? Stateless. It does not keep state between different message exchanges. That's right. Request and response pair. It's how communication between host and client occurs. Correct as well. Status code, a set of codes that identify the type of response provided by the server. That's also correct, so we have all of the above. Da-da-da is the HTTP request method or action used to send data from the client to the server. Send data from the client to the server. When I send data, when I send it, I'm the client, there's a server there. I'm sending the data, I post. When I access the site and I type google.ca, I get the site. I get a read-only copy. But if I send information, I send via a post. If I send data, if I fill out a form, I'm using a post here. Yep. Did I? Yep. Okay, so which is the most common HTTP status code? 200. Hopefully 200, because it's all good, okay. And what is the status, the HTTP status code for errors? DNE. So 500 and 400 client-side, client errors, server errors. Okay. That's it. How did we do here? Let's just have a peek. Okay, good. So kind of 2/3 there. Okay. Again, I hope that as we go through the questions that you get clarifications about what you didn't get too well. Okay. Let me see if there are any questions lingering around. No, just little things. Okay. Status codes. Okay, just a few references for your own sake. I mean, if you want to get more information about HTTP, you can find tutorials here. You can find plenty of extra information over there. A quick summary. Again, going back to the messaging. Client sends a request, an HTTP request to the web server. Web server receives the request. The web server runs an application. This is what we're going to be spending, where we're going to be spending a lot of our time here. The server runs an application to process the request. That's what we're going to be coding on MVC, using C#, using .NET Core, right? This. The server returns back to the client an HTTP response as an output to the browser. And the client receives the response. Okay? Great. So I'm going to our last set here. And I always pick the wrong one. Okay. Introduction here. Okay, so again, I don't have the intention of making this a session about HTML nor about CSS, but we're going to be talking briefly about them. Maybe for some of you this is basic information. Maybe for some of you this will work as a recap. But again, stick around, and this is the last time that we're going to be talking about HTML, CSS. Not as a user, but more more about the explanation about those elements. Let's go through it. So again, a bit of introduction here. We're going to have a bit look at the history of the web, but I'm not going to spend too much time on certain slides here. This is all available to you if you want to get to more details. Again, I'll be talking about some of the components of web development, what it means to be a well-formed web page. Okay, as I said, I'll brush through a few ones quite quickly here. So at the beginning of times on the web used to be all about hyperlinks pointing from one document to another one, locating documents. But very quickly, when commercial websites started to appear, we started to need the websites to be visually appealing. So we start to use things like CSS. Okay? But then sites became more demanding. We needed to have to build them and make them more interactive. So we had a language that could be used in the client side to make sites more interactive, and that's where JavaScript came to place. Okay? But so now we have rich websites, but we also need powerful languages on the server side to be able to produce, to be able to create and manage and generate complex systems. So we start using things like ASP.NET. Back in 2002, Microsoft came up with .NET framework. It was one of the initial versions of the .NET framework. It had a long life from 2002 up to, actually it's still valid. I mean, there are still plenty of companies that are still running very traditional ASP.NET framework. However, more and more, they are migrating to the core, to a more slim approach to server-side programming. ASP.NET framework, the main framework, is very bloated. There is so much data that comes back from the server to the clients. There's something called view states. View states is something that keeps growing. It's a piece of code in HTML that keeps growing and growing. So again, the traditional .NET framework in ASP.NET is not very, it doesn't perform that well. And that's when Microsoft, a few years ago, just about 4 or 5 years ago, it started to come up with the core, .NET Core, which is a slim version, much more efficient. You have complete control of the output HTML that comes from the server to the client. We have, as developers, you're going to see, we have complete control. Differently from when we are using traditional ASP.NET, that some of the things were created by the framework itself. We don't have control over certain aspects. And again, that's why we are using modern approaches like MVC. And this is just history of the internet. I don't want to go through those things. A few of terminology aspects here, web page, URL, URI, you have seen a little bit of that. All URLs are URIs, but not all URIs are URLs. Tongue twister there. Okay, so websites is the location of the internet that web pages are stored. They belong to a company. Web browsers is what we're going to be using to display the pages. And we go back again to our old friends, request, response. We have a client and we have a web server. Quickly, the diagram once again, we have the request from client to server. We have a response from server to client. Again, web server. And then clients, we have a bunch of different browsers. I really like using Google Chrome because of its developers' capabilities and how friendly it is for developers. Again, that's all in the client side. Just want to briefly mention that the World Wide Web Consortium is a group of companies that come together as a third-party organization that oversees the development of the standards of the web. Okay. Open source. Who can tell me what open source is, aside from reading from that? I mean, I guess that who can give me an example of open source? Linux? Linux is an open source what? An open source? Is that a language? Is that what is it? An OS, operating system, okay? What about languages? I mean, can you tell me any languages that are open source? Java. What else? Python. Which one? C++. I think it is it?
Yeah.
What else? PHP. PHP. So again, actually, I'm not sure if C# is. I know that .NET Framework is open source. Okay, so you can actually download the .NET Framework and open it up and change it if you want. You know, that's a recent change in Microsoft's approach. You know, and I think that's one of the reasons why they have surged again as a big player in the industry. We have discussed a lot about HTTP protocol. That's fine. We are done with that. Host computer. Host computer is a server. The server that is hosting the website, the web pages. Domain name. centennialcollege.ca, google.com. Those are the domain names. The unique address that they map back to IP addresses, to numbers on the web. So you have a friendly name that maps to an IP address number. Again, more of HTTP. Okay, a domain identifier is the last part of the domain name. See, we have a breakdown here. We have the protocol. Most of the protocols right now that are used are no longer HTTP. They are HTTP. What? S. They are all secure. We're going to be using a bit of both, you know, when we are doing our developments. We have the domain name. This last part of the domain is called the top-level domain. It can be .com.ca. This is a bit outdated. You're going to see that in MVC. This is no longer the case. You don't have a directory. You don't have a file name in MVC. We don't have a file name called index.html. Well, actually, we may have one. But the addresses are not pointing to a page. They point to an action. The address, they point to a controller. So again, those are the different concepts that we're going to have to adjust what we knew to this new approach by using MVC. Okay? See if there's anything going on there. Okay, someone is tired there. Me too. Okay, so TCP/IP. Again, there's nothing too different here. Just more of the same. Okay. Two-tier architecture. Now, again, we have a server and a client. We have the client front end. We have the server as back end. What is a full stack developer? Who knows what is a full stack developer? Somebody that can handle both. Good at JavaScript, good at HTML, good at CSS. Not necessarily good at the pure JavaScript, but maybe one of the frameworks. Tell me a few frameworks, a few JavaScript frameworks. Angular, jQuery, a few CSS frameworks. Bootstrap. We're going to be using Bootstrap. Okay, we're going to be using out-of-the-box Bootstrap in our applications. Okay, and then we have the backend. Our choice of backend is C#, MVC, Visual Studio as our IDE, SQL Server as our database. Again, front ends, back ends. One note here, server will be responding HTML back. It can have CSS as well. It can have JavaScript as well. What else it can bring back? What other types of files it can bring back? JSON, true, very true. XML, come on, more types of files. When you open a web browser nowadays, you see that type of file right away, right there. You don't see just pure HTML, you see, what else? Videos, media, pictures, images, JPEGs, GIFs. No? So again, the server can serve a lot of stuff. You're going to be focused on those three main elements, okay? Someone, I don't know which section was that, sent me an email asking if we're going to be using Photoshop, Adobe Illustrator. Are we using that? No, because this is not a design course. However, when it comes to web development, there are different aspects that someone has to deal with. There is the web page design, which you're going to be using something like Photoshop, Illustrator, or any other graphical design tools. We're not going to be using that, but it's called the web design. Then we have web page authoring, which is more of creating the HTML that will be output to the clients. We're going to be doing some of this. We're going to be touching on some of the HTML that you're going to be producing back. But our focus really will be on web development, web programming with C#, MVC, using MVC. Okay? Okay, so as I said, oh, actually, you know what? Let's have 5 minutes before I get to HTML. Almost done. Come on, 5 minutes. No problem. Go ahead. No problem. No worries. No worries.
What's the bonus assignment?
Yep.
Is it due tonight?
The first bonus, yes. But 10 o'clock, we're going to pause, and then you're going to have a chance to take care of that, okay? But make sure that you have some notes about the different aspects of that diagram that we have been talking about.
Okay.
And then by 10 o'clock, you're going to have a chance to put your thoughts together and upload that, okay? What's up? Yep.
When you make a payment system, what did you use? Like, did you,
Behind the scenes,
yeah,
I'm using something called the Stripe.
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 Very easy, very simple, very good to use.
What about using the PayPal API? Not good.
I'm not a big fan of PayPal. PayPal, to me, it has a lot of it's becoming hard to work with. Stripe is so easy. It's so easy from a developer perspective. Much easier than PayPal, to be quite honest. PayPal, you don't control the client's information too much. With Stripe, you have entire control. So I really like to use Stripe. It's Stripe. Stripe.com.
Okay.
Have you heard about Stripe?
Yeah, I
Yep. Stripe is. I'm a fan of Stripe. I use Stripe for 5-6 years now. Very good.
Thank you so much.
No problem. Okay, so let's carry on here. We have half an hour just to cover a few things, brush through HTML, share a few resources, and get our bonus covered here, our bonus done. So HTML, hypertext markup language. It's a plain text language. You can use any editor, text editor to change it. However, we are using what is our IDE. First, what is IDE? Integrated Development Environment. Which one is ours? Visual Studio. So you're going to be using Visual Studio. There is a segment here that I'll be talking about Visual Studio in the next bit here. Okay, so we're going to be using Visual Studio to do our coding, including HTML as well. Okay, so again, HTML is one of the pieces that comes back as a response. Our code will render HTML as views. So you're going to be creating, here's MVC, view. The view part is usually all about HTML, the V of MVC, okay? Again, as I said, this might be basic for some of you, maybe not that basic for some. HTML tags are what will distinguish the different elements in the page. We use brackets to identify different tags, paragraphs, headers, and divs, and a lot of other tags. We use forward slash, is at the back, yeah, forward slash, to define a closing tag, okay? In HTML, we have elements. Elements works in pairs. You have a value. We have a property and a value. The content is usually the part between two tags, the opening tag and the closing tag. We can have empty elements. Can you tell me one empty element of HTML? Anyone? Any element comes to mind? I can think of two. A line break, which is a BR. Line break, it's an empty element. There is no content inside. It's just to indicate a line break. And a horizontal line in HR is another one for a horizontal line. It's called an empty element. We have a few elements here. Some of those elements are, I would call it, deprecated. They are no longer that much used anymore, like the center. If you see a page having a center tag, you know that developer there is an old school developer. Okay, center is not much used anymore. Let's have a look at this video here. Again, it's just a video going through a few of the basic concepts of HTML.
In this video, you're going to learn about using HTML to add structure to your web pages. HTML stands for Hypertext Markup Language and is found on all websites across the internet. There are a bunch of different HTML structures you can use on your web page, including headers, lists, paragraphs, links, and images. Let's take a look at how to create a paragraph in HTML. The sentence we wrote for our web page would look better if it was distinctly different from the title of the web page. To separate the two, you need to let the computer know that all of this text is a part of a paragraph and not the title. You can do this by creating a paragraph element. Most elements are made up of three main parts: an opening tag, the contents to be displayed, and a closing tag. Tags are a part of HTML language, and they signal to the computer the start and end of an element. In this case, it's a paragraph. Tags let the computer know what we want to display on the screen and what we don't want to display. That's why tags include special characters like the less than and greater than to distinguish from the content. Paragraphs are just one type of structure you can use in a web page. Soon you'll learn about a number of other structures that will give you even more power to customize your website.
Great. Okay. So let's see here. Again, let's just have a look at some of the elements. We have the root element. HTML is a root element. We have the header section. Don't confuse the head section of the HTML with the header of the message. Okay? What you see inside of the HTML is the body of the response. But that body of the response, it has a head, and it has a body of its own. Slightly confusing, but again, the response message has a header and has a body. That body is the HTML. The HTML has a head section and has a body section. Who got completely confused by that? You got confused? Okay, let's go once again. So we have a request that goes to the server. Google, give me google.ca. Google.ca comes back. That message that comes back, that message has two components. A header, which is those little tiny bits that we saw here in, here. So that's the header of the message. And the body of the message is this. This is the HTML. So in the body part of the message, the body has a head and has a body too. But it's a HTML head and a HTML body. So it's you can almost think like, here's the message. We have a head for the message, a header for the message, a body for the message. In the body, it has a little head and a little body as well. So it's a body inside the body, a head inside the body. That makes sense. We have a body. The process of rendering, of reading the message that comes back and showing in the browser is called parsing or rendering. Again, getting that HTML and displaying in the browser. Okay. Again, P for paragraph, BR for a line break. As I said before, HTML editor, any text editor can be used to edit HTML because it's plain text. And what does it mean to be a well-formed document? A well-formed document, it's a HTML page that has the correct elements on them. Which correct elements? You see, a well-formed document must include the very first tag is a tag called doc type. And then we have the HTML tag, which encompasses everything. And then inside the HTML, we have a head tag, and then we have a body tag. Okay, and there are a few other things. HTML, is case sensitive. Okay, it's talking about well-formed. So to be a well-formed document, tags in general, they need to be lowercase. However, if you put uppercase in your tags, it will still display properly. It may not be a well-formed document, but it will still display correctly. If you still need some information about HTML, maybe a crash course. This is a 1 hour long crash course on HTML. Again, this is shared on Centennial as a PDF. This is a clickable link on your PDF that points to a HTML crash course for absolute beginners. If you need that, it's there for you if you want to review the details about HTML. Let's practice a little bit about HTML here on another Nearpod. So get back to your Nearpods. We're gonna go through another session here, and this is the codes on Nearpod. I think it's about 8 questions. IBLKA. So I'm gonna give here 3 minutes, and write down your notes about HTML, what we have discussed here, request, response, so you can be ready for 10 o'clock that we can just dump that in a Word document and upload that to Centennial. Okay, so let's go through the 8 questions. Who is making the web standards? C, the World Wide Web Consortium. Yep, that's the one. Choose the correct HTML element for the largest heading. So, heading, H6, well, I guess that's the bigger the number, the bigger is the header. H1 is the biggest one, okay? Traditionally, is the biggest one and should also have one H1 in each page. That's the general rule. What is the correct element for inserting a line break? It's a BR. So break does not exist. What is a B? For bold, okay? For bold. What is the correct HTML for adding a background color? So C, okay, so background tag does not exist. Body has a background property, but it's not called BG, but it has a background property. Body style, what is this inside? It's a CSS. It's a CSS. It's an inline CSS. Okay? And background, what that is. So again, that one here. Choose the correct HTML element to define emphasized text. B. So italic does not exist. B is the one, emphasized text. I, what is that? Italic. So in a way it might be similar to E, but again, this is italic only. Emphasize, it may have a different styling. And emphasize does not exist. What is the correct HTML for creating a hyperlink? href. Yes. So yep, we have the winner is A. The problem is here is name. The problem here is URL. This one is the correct one. href. Okay. 7. Which character is used to indicate an end tag? C. And last but not least, how can you open a link in a new tab or browser window? Which one? B or C? Okay, so the problem with C is that it's not just new, it's underline new. It's underscore new. There is an underscore new, but there's no new. So, but there is an underscore blank. So this is the one. Okay? Perfect. So how did we do? Let's have a look here in aggregation. Let me hide the students here. Okay, we're doing well. So HTML, woohoo, well covered here. Great. Now CSS. Okay. So let's see what we have there. Let's see what we have there. Okay. So let's have a look. Let's have a quick look at this video here. I'm not gonna talk too much.
Interests you have. As you've been building your websites, you've learned to use HTML to give it structure. We've learned to define headings, lists, paragraphs, and images to make your website start to look the way you want. But usually just giving a website structure isn't enough. You want to give it style to fully bring the content to life. The same website about fitness could have a sleek and simple style or a quirky and eclectic style, and each would feel different to your user. Web developers can control the style of a web page using a language called CSS. CSS stands for Cascading Style Sheets. CSS allows a web developer to define a specific set of style rules to apply to HTML elements on the page. Let's take a look at how to use CSS to create style rules for a simple web page about fitness. First, we'll write the CSS to turn all the paragraph text purple, to indicate that we want to apply a set of rules to all the paragraph elements, we write the name of the tag P followed by an open and then a close curly brace. We refer to the P here as the selector. The selector indicates the type of element the style rule will apply to. Next, we need to indicate what about the paragraphs we'd like to change. In this case, we want to change the color of the paragraph text. This part of the rule is called a property. And color is just one of the many properties we can change about a paragraph. A property is followed by a colon. Finally, we need to specify the value we want for that property. To make the paragraph purple, let's add the word purple after the property. And finally, add a semicolon to indicate the end of the style rule. The CSS that we just wrote is called a rule set, because like the name implies, it's a set of rules to specify a style for the selected element. We can add multiple property value pairs to the same selector to further control the style of our web page's paragraph elements. If we want these paragraphs to be purple and large, we can add the font size property to control the text size. Then specify a number value to set how large the font will be. CSS allows for all sorts of style rules: fonts, positioning, size, and colors. The more style rules you learn, the more you can make your web page tell the story you want.
Awesome. Okay, good. Okay, so again, one more type that will be served by the server. I'm not going to repeat what she mentioned already there. We're going to have a quick exercise to talk about CSS as well. 3 types of CSS. Inline styles. What does it mean to be inline? We just saw one style that was inline. What is that?
Background color.
Well, background color can be inline, can be in any one of those 3. But what does it mean to be inline?
In the code,
It's inside the tag, inside the HTML. Now, internal style sheet is also inside the HTML, but it's not inside the tag. Internal style sheet is inside HTML, but in a block called the style block. So you can have a style block inside HTML with a bunch of definitions of style sheets. However, the most appropriate place to put style sheets at this point in time are in external files. Why? Why?
Because this way they can be shared among several pages.
That's a great reason. So if you put externally, the CSS can be shared throughout the site. What else? What else is a benefit?
The HTML page remains lean, readable, and passable.
Okay, great. So it saves some back and forth with the server inside the HTML. In terms of performance, that's a good performance aspect. What is another performance aspect that makes external style sheets good use?
We can share across different projects. For example, we can put on a CDN bootstrap.
Okay, that's very close to that, to what I'm thinking. Go ahead, Shane.
Or when you easier to read,
Easier to read, okay.
or when you work with like other developers, some front-end developers will specify for their CSS, then just give the file CSS file to the developer. And if you're really good at just JavaScript, then you can just get the file JavaScript file in HTML. So that's separate. So that's why it's really good for separate.
So it helps when you are working in a team that you have developers and you have front-end developers. But let's think about performance. I'm going to give you a keyword to see if that sparkles anything on your.
Can be passed after the page load, so the load of the page can be progressive.
Okay, that's a good one. Go ahead.
You need to make any change, you have only one place to go.
Also another benefit from a developer standpoint. But let's think about, I'm going to give again a keyword and let's see if that will juggle your memory a little bit or your head a little bit. Caching. I'm not talking about caching. I'm talking about cache. Again, not money.
The browser cache.
The browser cache. What is the browser cache? What is that?
Well, it's a series of files that the browser downloads in order to parse the page, in order to visualize the page. And obviously, if the file was already downloaded, there is no need to get it again.
That's what I was trying to get. So if you have external style sheets, when you access the website first time, that those style sheets, they get cached locally in your system. When you visit different pages, if they use the same style sheet, that trip to get a new style sheet will no longer happen because the style sheet is already local to your browser, okay? So it saves trips as well. It helps with performance too, okay? That's what I was also trying to get. But very good response here. Again, if you need a crash course on CSS, use this link. An hour and a half, just CSS for the very beginners. I'm not going to go through that, but you're more than welcome to give it a shot there. I had a quiz here. I will come back to this quiz if you have time, because time is running short. I want to jump to JavaScript. I'm not going to talk about JavaScript, because you're not going to be, again, JavaScript is just another piece that gets returned. Because you're not going to be using JavaScript that much, I'm not going to be covering that. I'm not going to be talking about that anymore. Again, this is the entire point of this whole course. ASP.NET Core, MVC, and C#. This is the server-side scripting that you're going to be using, server-side coding. Again, this is just some information about server-side. We're going to really dig into this in the future from next week on. This is really where all our course will be focused on this application layer right here in the server. That's where MVC, C#, .NET Core is sitting, okay? Okay. Again, we're going to be using a lot of object-oriented programming. .NET Framework, keep this in mind. We're going to be working with .NET Core, not .NET Framework, okay? .NET Framework is the old stuff of Microsoft. It's still current, it's still available, but it's the previous technology of Microsoft. You're going to be working with Microsoft.NET Core. Okay, that's what I want to focus a little bit here. So our IDE, our integrated development environment, is Visual Studio. We're going to be using Visual Studio 2017. But Anderson, we are on 2019. How come we are using 2017? Well, the book is based on 2017. The content is based on 2017. Everything you're going to see on 2017 is translatable. It's directly applied to 2019. So again, there's nothing that you're going to be missing out because, yeah, we have VS 2019, but again, nothing that has been covered, that will be covered in this course, will be impacted by that. So again, we are safe to still be using 2017. What I want to show is how you can get 2017 on your laptops. In the stations here, it's all available, but if you want to download, you can download, and the instructions are available on eCentennial. So if you go to eCentennial, under Content, if you go to General, you have a PDF here that shows step-by-step how you can download Visual Studio using your Centennial credentials, because we have access as students and staff. And on top of that, if you're going to install that on your laptops or computers, make sure that you have a look at this link here to include LocalDB. Now, will this work in Macs? I don't think so, Shane. I don't think so. Because LocalDB, I don't think that there's a version of LocalDB for Macs. So it may not work on Mac. Okay, oh, so you gave up and then you went for that? Awesome. Good decision. So again, if you are Mac user, most likely you're gonna need something like Parallels to have Visual Studio running there, okay? And again, make sure that you install LocalDB. For instructions on LocalDB, look at this link here. It's just one more checkbox when you're installing Visual Studio, okay? Great, I wanted to cover that one. Okay, that's all good. So, two things left. One is, I want to quickly mention about bonus 2. I know that we haven't even done bonus 1, but I want to mention bonus 2 already because as soon as you are done with bonus 1, right, in the next few minutes, you can just leave, okay? Bonus 2 has been already placed on eCentennial, and the way you're gonna do that is here on week number 1, you have this description. Follow and practice the first 3 videos of Part Invites. Part Invites is the project that you're gonna be practicing the first. Here is a playlist that has 6 videos. It has 6 videos. What I'm asking you is to go through the first 3 videos. The first 3 videos, it's half an hour long. So you go step by step by step. You're gonna do whatever it's showing the video on your Visual Studio. Do that at home. Do that before the start of next class. So by 6:30 next Friday, you should have uploaded 3 questions about those 3 videos to eCentennial under bonus 2. Again, just go through those 3 videos. It will show, I was the one that recorded this. It will show step by step on how to go about this project. It will give you an introduction to MVC. Then we're gonna carry on for the rest of those videos, and I'm still planning next class, but we're gonna carry on from there, from the 3rd video onwards. So this course will require you to do homework. If you have not done those 3 videos by the next class, you're gonna have to do that during class. So that's the other thing. Bring headsets to class. Because if you need to follow some of those videos, you're gonna follow them on your own pace. So see if you can bring some headsets so you can follow those if you require them. Okay? But again, this course is a collaboration. You need to do some homework to get ready for the class. I'm not the only one speaking for 4 hours straight here. You're gonna have to do some work at home, bring some knowledge to class, bring some questions to class. That's the whole point of bonus number 2. You bring 3 questions, upload them to eCentennial, and we're gonna address them. We're gonna address some of them. But again, every class, I will have a follow-up for you to do at home that will take you about an hour to get done. Even though it's 3 videos in total half an hour, but because you're gonna be pausing, you're gonna be following, it will take an hour, maybe an hour and 15 minutes to get them done. But again, my classes, they are different from what you have seen out there, okay? So again, I'll need your cooperation to work together and build a more interactive. I do a lot of flipped classes, and this is part of that. Any questions? Okay, so for bonus number 1, let's use the next 18 minutes here. Write down, build the diagram on Microsoft Word, write down server. What did you understand about the server? What did you understand about the client? What is a request? What is a response? HTML, JavaScript. Again, list them up, put down your notes there in a Word document, upload, and that's your bonus number 1. Okay? Any questions? Shane?
I already did notes, so I can just upload it.
Just upload. Yeah. If you have done already, just upload.
How long is it gonna, how many words?
How big is it? The 1 page. 1 page should just be enough. No? Yeah, 1 page, I mean, what is that?
For 1 page.
For the whole thing? Yeah, it can be 1 page. I mean, if you have a diagram at the top, and then you have a bullet point of server, this is what I got from server. And then you just put 1 line, 2 lines of description of what you got about that. Again, I just want to make sure that you had a chance to to jot down some notes about that. Someone had raised hands. You did, Dimitri? Yeah, you.
I just would ask you what actually, just to show the diagram.
Build the diagram on your own, and then for each aspect of the diagram, you have the server, you have a response, you have a request, you have a client, you have JavaScript, you have web application. See what you can write down about each one of those elements of the diagram, okay? Yep, no problem. You can do, but as long as you export that as an image or export that to, because I got a visual file from a few students and I couldn't open that. I was not able to open it. But again, if you want to do the diagram in visual, you can just do a print screen of the diagram and paste it on Word, okay? Sorry, I missed a few questions on the board, but again, you can keep going. For the ones that asked, I'll just mention out loud, and I hope that will still be useful. Can you explain why external style sheets is the best way? Well, I think I covered that, mostly because it's reusable, because you have the ability to cache the files, so performance gets better. So I think that we covered that. So Visual Studio 2019 is not good at all for it. No, you can use Visual Studio 2019. You can. So that's a good question. You can use. Yeah, you can. You should be able to. I think that files on 2019 can still be open on 2017. I'm actually going to try that. For now, my answer will be yes. You can use Visual Studio 2019. Do we need to cover web development topics for a bonus one? No, just cover the topics that have been discussed in the diagram. So you have request, response, server, client, web application, the web application, you have JavaScript, CSS, HTML. Cover those main points in the diagram, from the diagram. For bonus, do we need to create a diagram as well as explain what each means? Well, the idea is to reproduce the diagram. I can even keep the diagram open here so you have a quick way to see it. Again, I just want to reinforce because I really like to use diagrams as a way to consolidate concepts and information and knowledge. Okay, I see some other questions here. Can you recommend some video for coding to have to know what we learned before start next class? Well, I mentioned already about the videos for HTML, for CSS. I mean, that's a good place. But the videos that I recommend for the exercise, the next bonus, that's a good video to get going. If you want to go for it, you can do all 6 videos. I mean, if you have the time, that's fine. You can get ahead of yourselves, ahead of the class.